Geometry Unit 7, Quiz 3, Day 15. This is our last quiz for the unit. And we're working with circles here. So number one, we need to find the circumference. And our circle has a radius. Remember, the radius goes from the center to any point on the outside is 12 inches. And so we want to leave our answer in terms of pi. Circumference equals diameter times pi. All right, pi, remember, is an irrational number. It's approximately 3.14. So what's our circumference? Well, we need the diameter here. Okay, so we can also say that the circumference equals 2 times the radius times pi. So our radius is 12, so we just substitute 12 in for r, and we get circumference equals 24 pi inches. And there's our answer. Number 2, it says name the major arc and find its measure. So we have center C right there. That's going to be 50 degrees. All right, we have A and B. So the major arc, this is point D. The major arc is going to be from this point around there. All right, that's the major arc. Okay, it's the larger of the two intercepted arcs. So we have this measure here is 50. So the measure of the rest is the rest of the circle. So you just subtract from 360, and arc ADB equals 310 degrees. A team in science classes number 3 placed a chalk mark on the side of the wheel and rolled the wheel in a straight line until the chalk mark returned to the same position. So they roll this wheel, right, and it's rolling, and it rolls like that, right, and it gets back to where it started. All right, so basically the whole circumference of the circle was rolled. And so the team measured the distance the wheel had rolled and found it to be 15 centimeters. Okay, so the circumference is 15 centimeters. That's the distance around the circle. To the nearest tenth, what is the area of the wheel? Okay, well, you can find it because you have the circumference. Well, the area is pi r squared, right? Pi times radius squared. Well, the radius is half the diameter, and the diameter, if the circumference equals pi times d, well, you just rewrite this and solve for d, so you divide both sides by pi, so the diameter equals circumference over pi. So in this case, the diameter equals 15 over pi. Alright? So now you have the diameter. If the radius is half the diameter, then you can say that the area would be pi times 15 over 2 pi squared. All right, because that's your radius here. It's half of your diameter is 15 over 2 pi. So pi times the radius squared is pi times 15 over 2 pi squared. So now we can rewrite that as pi 15 squared is 225, and 2 pi squared is 4 pi squared. I'm sorry, 2 pi, yeah, 2 pi quantity squared is 4 pi squared. And so we can take off one of those pi's there, and we get 1. And then 225 divided by 4 is going to give us 55. And then we have 1 pi left underneath. So it's 15 divided by pi, and that's going to be approximately 17.9 centimeters squared is our area, which is letter C. All right. Number 4, find the length of arc XPY. We got a circle there. This is a right angle, 12 meters. This is XY, and that's P. So basically we're dealing with this arc here, and we have this arc here. Well, this is a central angle, so that arc is going to be 90. And then we have this arc is the rest of the circle. So 360 minus 90 is going to give us 2 270. And so we have to find the length. So that's going to be 270 degrees there. The radius is 12 meters, and we want to find the length of the arc. So remember, circumference equals pi times d, right? So in this case, the circumference is going to be 24 pi meters, right? So if we want to find the distance of an arc, or the length of an arc, we take how many degrees it is, and we're going to have it as a ratio of the whole circle, just like that. And we're going to multiply it by the formula for the circumference, because we're just taking a certain, you can say as a portion of a circle. We're going to take a certain ratio. In this case, it happens to be 3/4 of the circle if you reduce 270 over 360. So we're going to multiply that by 24 pi. Well, that's going to give us, if you reduce, is going to give us 3/4 times 24 pi. Well, 3/4 times 24 is just 18. So it's 18 pi meters is the answer, and so that would be letter B. Number 5, we have find the area of a sector. So again, we have to use our area formula as pi r squared, but we're dealing with a sector here. That means an area of a circle, like a section, like a slice of a pie, so to speak. And we have a central angle of 140 here, and we have the diameter is from there to there is going to be 6.5 centimeters. So we want the area of this sector, which is kind of encased right here. If you had a pie, you cut this all off, what would that area be? That's right, enclosed by this arc and these angles. What's that whole piece? What's the area of that piece? Okay, so we have our area of the whole circle. Now we want to know what part of this is going to be the area that we're talking about. So basically we're going to subtract, we're going to have a ratio out of 360. Again, the central angle is 140, remember, so the arc is the same length, or sorry, same degrees. So it's 140 degrees, and what ratio of it is of a full circle? Well, that's 140 over 360. And then we're going to use our area formula to find this out. So the radius is half the diameter, remember, so it's going to be 3.25, and then we need to square it, and then we need to multiply it by pi. So it's really, this is the area here. Okay, that's my area formula, but I need to get a portion of that full area, because I don't want to get the full circle. I just want to get this part right there. So how much is that part? So I have 140 over 360, which reduces to 7/18 times 3.25 squared times pi. And that's going to give me approximately 12.904 centimeters squared. So I just round off to 12.9 centimeters squared. I'm still dealing with area, so I have to put my units in square units. Okay, number 6, find the area of the circle. Leave your answer in terms of pi. Here it is. My diameter is 5.1 meters. Area is the radius squared times pi, right? So I just have to divide 5.1 by 2. So my radius is 2.55 meters squared times pi. And so the answer is 6.5025 pi. And there he goes. Number 7, find the area to the nearest tenth. I have kind of 155. 9 inches is my radius. I'm assuming this is a circle where this length equals this length. Okay, it's going to be important that it is a portion of a circle. So my radius here is 9, and my angle is 155. So again, it's going to be that arc measure is going to be the same as the central angle, and so I would just do 155 over 360 is my ratio, and then I need the area. So again, it's pi r squared, right? So our radius is 9, so it's going to be times 9 squared times pi. So I get 155 over 360 is 31 over 72 times 81 times pi. So that's going to reduce down to 31 times 9 times pi, and then that's going to give me 279 pi inches squared. Now for number 8, I have a circle. This is a tangent line. Let's just get a nice tangent. Okay, assume that's a tangent. There's my diameter, there's the center. D, B, I know it's a diameter because it goes through the center. Also, it tells me that BD is a diameter. I have point C here, I have A there, and that's R right there. So this is tangent. That means it forms a right angle there. I have a segment going from B to C, and then from C to A. And it wants the measure of CBR. It wants a measure of this angle. All right. It also gives that one is 25. Let's see if I can write it in there. Let's redraw that line. Okay, so that's 25 degrees. Let me just write it. Draw a little arrow. It's right there. Okay, so basically, I have this whole angle is 90. This part is 25. I know that these then are complementary angles. So angle CBR plus 25 degrees is going to be 90 degrees because that's tangent and it forms a right angle to the. Okay, so in number 9, I want the measure of arc PQ. I want that right there. So I have this is 50, this arc is 140. Since this is an ascribed angle right there, I know that the arc that's intercepted is twice the amount of that angle, so I know that arc is 100 degrees. And so I just need PQ. Now, well, I know these two, which are right next to each other, so the total of that is going to be 240 degrees. All right? And so the rest of the circle, remember, is just going to be the difference from 360. So I just take 360 and subtract 240, and I get 120 degrees, and that's my answer. So it's D. Number 10, I have intersecting segments. I have A, B, and C, D are chords intersecting at E. Okay, that's 5, 12, 6, and then I need to find this segment right there. That's going to be DE. I need segment DE. Alright, I'm trying to look for that. Alright, now if you remember your theorem, it's going to be the product of those two segments that are cut are going to be equal to each other. So 5 times 12 is the same segment equals 6 times an unknown number, so it's just x. So I get 5 times 12 is 60 equals 6x, and that's easy. X is 10. So my answer is C. Number 11. We have circle again, center O. We have a tangent, and that's at point A. At point B, we have a secant going through there. We have point D, and that's point C. So measure of arc AC is 70 degrees. We know that this arc is 110 degrees. That's a measure of arc CD. And so it wants to find the angle of ABC. So that's the angle we want right there. So how do we find that angle? Well, it's intersecting outside the circle. So angle B, or angle ABC we could say, is going to be equal to half of the arcs AD minus arc AC. Okay, well you know arc AC is 70 right there, right? Well you need this. You need this AD right there. So how do we come up with that? Well, we know this is 70 here, 110 there. So what's that total? That's going to be 180, right? So the rest of the circle, remember, is just the difference. 360 minus 180 is magically 180, right? So now we have that measure of that arc, and so our angle is going to be half of the difference between that and 70 degrees, because that's this arc right here. So the difference between the two arcs, remember, they intersect outside the circle. So it comes out to 1/2 of 110, which is 55 degrees. And our answer is C for number 11. Number 12, point -32 lies on a circle whose equation is x plus 3 squared plus y plus 1 squared equals r squared. What must be the radius of the circle? So in this case, we're just going to plug in our x and y and solve for r. So here we have -3 plus 3 squared plus 2 plus 1 squared equals r squared. And everything else is just, it's basically just algebra 1. So it's 0 squared, so that cancels out, right? That's nothing. We can just ignore that. 2 plus 1 squared is, 2 plus 1 is 3, so 3 squared is 9. Or you can think of it as 3 squared equals r squared, and so r equals 3. So what's the radius of the circle? It's 3. The answer is A. So pretty straightforward. And that's the end of your day 15 quiz, quiz number 3.